Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer A, well done. If you'd like to hear my explanation of how I found the answer, please continue watching. So, which graph shows the variation of momentum p with the wavelength lambda of a photon? So for this question, I'm going to use the DeBroglie wavelength equation that you'd find on your datasheet. And that is the wavelength is equal to the Planck constant over the mass and the velocity of the particle. Now, this equation is actually given for a particle with mass, such as an electron or a proton. But if you look at the mass times velocity, that is the equation for momentum. So I could rewrite this equation as the wavelength is equal to the Planck constant over momentum, given by the letter p. Now light, for all sorts of relativistic reasons, has momentum, and its wavelength is inversely proportional to its momentum. So I'm looking for a graph that shows an inversely proportional relationship, and I know the shape of graph I'm looking for is this. Let's just have a look at the other answers and see why they're not correct. Well, D shows momentum to be directly proportional to the wavelength, so that's obviously not right. We're looking for something inversely proportional. For C, the momentum is again directly proportional to the wavelength, but this time with a negative correlation, so that's not correct. Both A and B at first glance appear to have a very similar shape. The problem with B, this shows that if the wavelength was 0, there would be a maximum value for momentum. Well, that's not true. If we divide the Planck constant by 0, then the wavelength is going to tend towards 0, as shown by A. I hope you found this video useful. If you did, press the like button. All comments will be welcome, and I hope you'll share and watch more of these videos in the series.